So today we're learning about division some more. We're going to take some division problems, and we're really going to focus on units of 2 because we are really good at counting by 2s, and we want to make sure that we have those 2's facts in our heads. And so our goal today is to interpret, that means explain, the quotient, the answer of the division problem. We want to be able to explain the answer to a division problem no matter whether it's talking about the number of groups that we have or how many objects are in each group. So that is our main goal today. So we're going to look at some tape diagrams and some arrays to solve division problems. But first, I want to wake your brains up with a quick review of this multiplication skill, and it's a property. So I want you thinking right now, which property could this be as I read the problem? You ready? Here we go. A chef arranges 4 rows of 3 red peppers on a tray. He adds 2 more rows of 3 yellow peppers. How many peppers are there altogether? So I'm thinking about this, and I feel like maybe I could draw an array. So I went ahead and let's do that with maybe we could use red for the red peppers and yellow for the yellow peppers. So let's do that. Here are 4 rows of 3 red peppers, and then we're going to do just like our chef did, and we're going to add 2 more rows of 3 yellow peppers. So here's my array. If these were peppers, then this is exactly what our chef's tray would look like based on what the problem told us. So we want to figure out the total. How many peppers are there altogether? So we need the total. Let me think. This feels like a multiplication problem to me. I hope it does to you as well, because I have this array. It's full of rows with columns, and I know how many are in each row. So if I look, I can count 1, 2, 3, 4, 5, 6 total rows with 3 in each row. So I know that equation is going to be 6 times 3 equals, we don't know, question mark. So let's see. How can we figure that out? Well, I could count all of them. I could do that. I'm not really very good with my 6 facts yet. I could count by ones. 1, 2, 3, 4. That seems like it's going to take a long time. Oh, I know what I can do. I'm looking at my array. Since I have 2 different colors, I can already kind of see 2 different problems within that. I can see 2 equations. Do you see them? Good. So the equation that I'm going to write for the red section of my array, I have 4 rows with 3 in each row. That's 4 times 3, and I know that equals 12. 4, 8, 12. And I counted the columns, but I know how to skip count by 4s. So now I'm going to write an array for, let me put that away. I'm going to write my equation for the yellow part of my array. And I did go ahead and leave a little gap in there when I made that, just because it kind of helps me see the colors a little better. So I see that I have 2 rows with 3 in each row. And I know 2, 4, 6, if I count the columns, that would be 6. So 2 times 3, 2 rows of 3 equals 6. So now that I know there are 12 red peppers and 6 yellow peppers, I'm going to add those numbers up, and that'll give me the total number of peppers. So 12 plus 6 equals 18. So does that also mean 6 times 3 equals 18? Yes, you're absolutely right. It does. So let's look. That was a property. Are you thinking of the name of that property? I hope so. It's the distributive property. Let's look at how that equation would look if we wrote it out in the distributive property. Thinking back to our original equation of 6 times 3, I used the array method, but if I imagine the alien method, where I take one of those numbers and I break it out into those little alien antennas like a number bond, what are those 2 numbers if I'm the alien? Here's the 6. Now I'm going to break it up. What are my numbers on my antenna going to be? 4 and 2, because I broke my 6 up into a 4 and a 2. So let's look at that equation. That would be 4 plus 2. Those parentheses show that that's where we took the 6 and we broke it apart into 4 plus 2, and then we multiplied by 3. So my distributive property equation would be 4 plus 2 in parentheses times 3 equals 18. So way to go. I didn't learn this until I was in middle school or maybe high school, so you guys are way ahead of the curve. Now let's look at a division problem. 2 students equally share 8 crackers. How many crackers does each student get? Got 2 kids, 8 crackers. Now, I'm not going to add those numbers up. I am not going to multiply those numbers because I see the words equally share. These words right here are keywords that almost always tell me to divide. So the total is 8 crackers, and I know I need to equally share or divide those among 2 students. So let's go with that. I'm going to draw a tape diagram because that's what we've been using in class to study division and to model it. So here's my tape diagram, and that represents the total of 8 crackers. So now visualize, where would I need to divide that tape diagram to make 2 equal parts? Kind of maybe look at your screen and kind of point to it. Do you see it? The lights just turned off, so now the color's a little different. All right, here we go. I'm going to put it right in the middle, and now I have exactly 2 equal parts. So how does this diagram represent the students? Are you thinking what I'm thinking? There are 2 sections because there are 2 students. So let's say their names are Billy and Bobby. Here's Billy, here's Bobby, and now we're going to figure out how many crackers each one gets. What is our unknown? It's the number of groups, or is it the size of each group? Yes, it's the size of each group. I can look at the tape diagram and see there are 2 groups. I just need to figure out the size or how many are in the group. How many crackers does each kid get? So let's work on that. I think that for this, I'm going to put 1 cracker in each section, and then I'm going to count 1, 2, 3, 4 until I get to 8. Here we go. 1, 2, 3, 4, 5, 6, 7, 8. Okay, done. How many crackers does each child get? Well, I can look in each section of the tape diagram and I see that there are 4 dots, and so that means that each child will get 4 crackers. Awesome thinking. Okay, let's try it again. But see, remember, our goal is to think about what the quotient, the answer to the division problem, means in different contexts, whether it's the number of groups or the number in each group. In our last problem, it was the number in each group. So that 4 meant that each kid, Billy and Bobby, each got 4 crackers. That's what the 4 meant. But let's change the problem a little bit. And now let's imagine each kid gets 2 crackers. There's still 8 crackers. And now every child or student is going to get 2 crackers. But we do not know how many students there are. The question says, how many students get crackers? So now think about this. Do we know the size of the groups, or do we know how many groups? Yes, we know the size of the groups. This time we know that there are 2 crackers in each group. So I'm imagining that tape diagram we drew, and I see more sections, but I see 2 in each section. So let's keep going and look at that tape diagram. So here we have our tape diagram, and the total, the whole thing, is going to represent 8 crackers. But now I need to know, if each section contains 2 crackers, how many sections is that going to be? So this time our unknown is the number of groups. We're trying to figure out how many groups there are, how many kids are getting crackers. So let's draw more groups of 2. How are we going to know when we're done drawing groups of 2? Well, we're going to skip count by 2s, and when we get to 8, we're going to stop, right? As soon as we get to 8, we're going to stop. So here we go. 2, we already have the first group of 2. 4, 6, 8. Whoops, Miss Medlin went too fast. 2, 4, 6, 8. So I can see that there are how many groups, how many sections in my tape diagram? 4, that's right. So let's write a division sentence to match the tape diagram. 8 divided by 4, 2, 8 divided by 2 equals 4. So this time our answer was 4, and it was the same answer it was before. We've done 8 divided by 2 both times. The first problem, the answer, the quotient told us how many were in each group. This time, that 4 has a very different meaning. It tells us that we have 4 groups, or to answer the question, 4 students get crackers. Very good. So The two division sentences for these diagrams are the same, but the tape diagrams are different. Both of these tape diagrams represent the equation 8 divided by 2 equals 4. But the tape diagrams are different because the 4 means two different things. In the first tape diagram, it's the second one on this screen, but it was the first one we used. The 4 represented how many were in each group, how many crackers each kid got, because we knew the number of groups was 2. We knew there were 2 kids, Billy and Bobby, getting crackers. But in this tape diagram that I'm kind of circling around with my arrow, the 4 represented the number of groups because our problem told us that with a total of 8 crackers, every kid got 2. 2, 4, 6, 8. That's 4 groups of 2. Okay, your assignment for today is going to be to work on the problem set for lesson 12. The link for that is in the daily agenda for Canvas, so you're going to want to make sure you click on that. I will also link in a video in Canvas for how to use the program that you're going to be using to solve that problem set.